Have you ever looked up at the night sky and wondered how our planet came to be? How did this tiny blue dot, teeming with life, emerge from the vastness of space? It's a question that has fascinated humankind for centuries, from ancient civilizations mapping the stars to modern astronomers peering through powerful telescopes. The quest to understand our origins has been relentless. The story of Earth's formation is a tale of cosmic collisions where massive celestial bodies crashed into each other, merging and breaking apart in a chaotic ballet. Fiery beginnings marked by intense volcanic activity and relentless bombardment from space debris. Yet from this chaos, life found a way to emerge, transforming a once hostile environment into a cradle for biodiversity. Out there, amidst the billions of stars in our galaxy, the Milky Way, countless planets orbit their own suns, each with its own unique story. These exoplanets, as they are known, come in all shapes and sizes, some rocky like Earth, others gas giants like Jupiter. Each one a potential host for life, each one a mystery waiting to be unraveled. The birth of a planet is a truly remarkable event. It begins in a protoplanetary disk, a swirling mass of gas and dust that orbits a young star. It's a process that takes millions of years, with particles gradually clumping together, growing larger and larger until they form a planet. This delicate dance of gravity, matter and time is a testament to the intricate forces at play in our universe. Gravity pulls matter together while other forces shape and mold it into celestial bodies. But where does it all begin? The journey of a planet starts in the heart of a cosmic nebula, a vast cloud of gas and dust. The raw materials for planets, stars and even ourselves lie scattered across the vast expanse of space. These interstellar dust clouds are the building blocks of everything we know. In these cosmic clouds of gas and dust, the seeds of new worlds are sown. Over time, these seeds grow and evolve, giving birth to new stars and planets. In these cosmic clouds of gas and dust, the seeds of new worlds are sown. They are the nurseries of the universe, where the next generation of stars and planets are born. The seeds of new worlds are sown, and from these humble beginnings, entire solar systems can emerge, each with the potential to harbor life and tell its own unique story. Imagine a giant cloud of gas and dust, a nebula, drifting through the universe. These nebulae are like cosmic nurseries, filled with the building blocks of stars and planets. Over time, gravity draws these particles together, pulling them closer and closer. As the cloud collapses under its own gravity, it begins to spin faster and faster. The center of the cloud heats up, becoming denser and hotter. Eventually, the temperature and pressure become so intense that nuclear fusion ignites. A star is born. Around this newborn star, the remaining gas and dust begin to swirl. This swirling disk, known as a protoplanetary disk, is where planets, including our own Earth, will eventually form. Our solar system formed from a protoplanetary disk about 4.6 billion years ago. Picture a giant flattened disk of gas and dust surrounding our young sun. Within this disk, tiny particles of dust, remnants from old stars, are constantly colliding and sticking together. This process, called accretion, is like building a snowman. As more and more particles clump together, they grow larger and larger. These growing clumps are called planetesimals, the building blocks of planets. Over millions of years, these planetesimals continue to collide and grow, their gravitational pull attracting more and more material. Some, like our Earth, would eventually become planets, while others would remain as asteroids or comets. In the chaotic environment of the early solar system, Earth began to take shape. Collisions between planetesimals released enormous amounts of heat, causing the young Earth to melt. Denser materials like iron and nickel sank towards the center, forming Earth's core. Meanwhile, lighter materials like silicon and oxygen rose to the surface, forming the Earth's crust. Over time, the Earth cooled and solidified, but the planet's journey was far from over. Gravity played a crucial role in shaping our planet. It pulled in more material, causing Earth to grow larger. It also shaped the Earth into a sphere, the most stable shape for a large object in space. Section 5, The Violent Beginnings, a Turbulent Youth. The early Earth was a place of intense heat, volcanic activity, and constant bombardment from asteroids and comets. One such impact, about 4.5 billion years ago, had a profound impact on our planet. A Mars-sized object named Theia collided with the young Earth in a cataclysmic event. This impact ejected a vast amount of debris into space, which eventually coalesced to form our moon. This period of intense bombardment, known as the Late Heavy Bombardment, played a crucial role in shaping the early Earth. It delivered water and other volatile compounds to our planet, essential ingredients for the emergence of life. Section 6, a blue oasis emerges, oceans and atmosphere. As the Earth continued to cool, water vapor released from volcanic eruptions began to condense in the atmosphere. This process was crucial in shaping the planet's future, as it led to the formation of the first bodies of water. The cooling of the Earth was a slow and gradual process, taking millions of years, but it set the stage for the next critical phase in Earth's development. Torrential rains fell upon the Earth's surface, forming the first oceans. These rains were relentless, pouring down for thousands of years, carving out basins and valleys that would become the cradles of the oceans. The sheer volume of water transformed the planet, creating vast bodies of water that covered much of the Earth's surface. These early oceans were likely acidic and hot, but they set the stage for life to emerge. Despite the harsh conditions, these primordial waters were teeming with the basic building blocks of life. The heat and acidity created a unique environment where chemical reactions could occur, leading to the formation of simple organic molecules. The Earth's first atmosphere was very different from the one we breathe today. It was thick and composed of gases that would be toxic to most modern life forms. This primordial atmosphere was a mix of hydrogen, helium, methane, and ammonia, creating a dense and hazy environment. It was composed mostly of hydrogen and helium, gases that were eventually blown away by the solar wind. The solar wind, a stream of charged particles from the sun, stripped away these lighter gases, leaving behind a more stable and life-supporting atmosphere. This process was essential in creating the conditions necessary for life to thrive. Volcanic outgassing released water vapor, carbon dioxide and nitrogen, forming a new atmosphere. This new atmosphere was richer in the gases needed for life, such as carbon dioxide and nitrogen. Volcanic activity played a crucial role in recycling these gases, maintaining a balance that would support the development of life. This early atmosphere, though toxic to us today, provided the necessary conditions for life to arise. The combination of volcanic gases and the energy from the sun created a perfect environment for the first simple life forms to develop. These early organisms would eventually evolve and adapt, leading to the diverse and complex life we see today. It also protected the Earth's surface from harmful radiation from the sun. The thick atmosphere acted as a shield, blocking out much of the sun's harmful ultraviolet radiation. This protection was vital for the survival of early life forms, allowing them to thrive and evolve in a relatively stable environment. Section 7. The Cradle of Life. Setting the stage. The early Earth, though seemingly inhospitable, possessed all the ingredients necessary for life to emerge. Liquid water, a source of energy from the sun, and a protective atmosphere provided the perfect environment for life's building blocks to assemble. In the primordial soup of the early oceans, life arose from non-living matter in a process called abiogenesis. Simple organic molecules, the building blocks of life, self-assembled and eventually gave rise to the first single-celled organisms. These early life forms, though primitive, were incredibly successful. They thrived in the Earth's early oceans, slowly changing the planet's atmosphere through photosynthesis and paving the way for more complex life to evolve. Section 8. A planet of constant change. Earth's evolution continues. The story of Earth's formation is not merely a tale of the past. It is a living, breathing narrative that continues to unfold with each passing moment. Our planet, a vibrant blue and green sphere, has been on an incredible journey for over 4.5 billion years. Our planet is a dynamic and ever-changing system. From the swirling patterns of weather systems that bring life-giving rain to the arid deserts to the lush forests that breathe life into our atmosphere, Earth is a masterpiece of constant transformation. From the slow march of tectonic plates to the erosive power of wind and water, Earth is in a constant state of flux. Mountains rise and fall, rivers carve new paths, and coastlines shift with the tides. These processes, though often imperceptible in our short lifetimes, are the very essence of Earth's dynamic nature. Over billions of years, Earth has witnessed the rise and fall of countless life forms, each leaving an indelible mark on the planet's surface. Fossils and remnants of ancient creatures tell the story of a world that has seen dramatic changes, from fiery beginnings to ice ages and beyond. From microscopic bacteria to giant dinosaurs, life has evolved in myriad forms, adapting to the ever-changing environment. These life forms in turn have influenced the planet, creating a complex web of interactions that continue to shape our world. Each era has left its mark on our planet, shaping the world we know today. The geological layers of Earth are like pages in a history book, each telling a story of a different time, a different climate, and different inhabitants. As we look to the future, we are reminded that Earth's story is far from over. The challenges we face, from climate change to biodiversity loss, are part of this ongoing narrative. But so too are the solutions we create and the actions we take to protect our home. It's a story that we, as inhabitants of this remarkable planet, are now a part of. Our actions today will determine the next chapter in Earth's history. We have the power to influence the future, to ensure that this planet remains a vibrant and thriving home for generations to come. Let us strive to understand and protect our planet, ensuring that its story continues for billions of years to come. By working together, embracing sustainable practices, and fostering a deep respect for the natural world, we can write a future where Earth continues to evolve and flourish.